Hey friends, I'm Rahul. Welcome to Animation Labs. Hope you like my previous videos. And today we are going to discuss one of the problem statement with the XOR concept with neural network with backward propagation. I hope तुम्हाला हे समजायला सोपं जाईल आणि आपण न्यूरल नेटवर्क बद्दल एक सोपं उदाहरण पाहूया. Okay, let's start with the example. This is my GitHub. यामध्ये तीन files आहेत. If you see, there is one diagram and there is code with the second file. Here is the code. I'll explain this and step by step and let us see. This is the third file which gives you the how the program is behaving, right? Step by step simulation steps. If you need it, the thorough investigation of the program, here is the explanation and how the program is getting simulated. This is in the third file. So let's start with the program. Yeah. So hey, let's start. This is the code. Okay, I explain the structure of the code first of all. But before that, we understand what is the data, input data that we are going to provide to the neural network. As you know, neural network is one of the important topic in the deep learning where we educate and train the models and learn and validate the input and output of the learning. And one of the example that we are going to see is neural network with backward propagation or the concept of XOR. You know what is XOR concept, right? Let us see the how the things are executed. This is my GitHub repository. I'll provide you the link of this GitHub repository into the video in the description. Okay, you can refer this then. You will see here. This is the first step. Okay, let us understand. So as you know, we have an XOR problem. Like we provide input with a 0 1 1 0 0 0 1 1, right? And then this input is provided to the neural network. And we what we are going to test is how the neural network is learning and how it is jumping to the conclusion with the predicted probability of the XOR concept for 1 or 0. That is, or we call it as a y hat, right? And as we know that 0 1 that leads to the 1. So our target is y target, and we have y hat as some probability, maybe near to 1 or maybe near to 0. And how we are going to deal with that, we will see. So, let's see. So this is XOR concept, we know. Okay, so we will provide input to inputs 0 0 0 1 1 0 1 1, and this is how the program should behave with the output and validate the output, right? So let's start with this. Okay. So here in this neural network, we have input layer with the two nodes, and we have hidden layer with the four nodes, and we are using activation function for the hidden layer as standard. You know the activation function. Activation function is a function that activates these nodes on certain assumptions, so certain weight and bias factors, right? And the final we have a single node output layer and the activation as like sigmoid activation function we are using here, and we are getting here some predictive like analysis figure that will take us to the near to the y target. Yeah, guys, let's understand. Once we are done with this, you can refer this in the GitHub. And once we are done this, let's move with the next structure of the program. So this is very simple program, and you will definitely understand it. I have flagged it with the print statement, in order to understand how the output is. So here we are using nothing but an NumPy, okay, and we are going to take a tiny database with the XOR concept. Like this is like the X that is the input, and we are expecting this output with this particular combination of the input, and we have the random seed factor so that we can get a consistent output for the consistent input from the neural network. So we have prepared one neural network class. This is the initialization functions. We are going to provide this particular constructor of the neural network with learning rate and hidden size, right? So this is the default values. Let us see. And in the initialization, we initialize the weight to the hidden layer, right? So W1 is shape and bias. Here we are going to assume the bias for both hidden layer and the output layer with 0. Uh, Just for the simple understanding. And here you will see this is the complete initialization of the neural network. Yeah. So we see on the first initialization, then we are going to use the like activation function, tanh. So we'll provide the input. Similarly, we will provide the sigmoid activation function. And this is actually the learning starts. So this is the forward propagation. And in the forward propagation, what is happening? I'm just explaining the structure of the neural network. This function defines the backward propagation. So what is backward propagation? You know that. In forward propagation, we provide input, we get some probability of the output. And once we get to the error, that is like target, the difference between the target and that is the predicted value of the output. And then we pass this particular error into the backward direction to adjust the weight and bias of the neural network so that in the next iteration, the neural network will understand. याच्यामध्ये तुम्ही पहा न्यूरल नेटवर्कचं जे बेसिक कॉन्सेप्ट असा आहे की ज्यामध्ये आपण इनपुट प्रोव्हाइड करतो अँड डीप लर्निंगमध्ये तो मॉडेल लर्न करतो आणि आपल्याला आउटपुट भेटतो. सो वन्स वी गेट द आउटपुट देर इज डिफरन्स बिटवीन टार्गेट व्हॅल्यू आणि आपल्याला जे प्रेडिक्टेड व्हॅल्यू मिळालेली आहे त्याच्यामध्ये एरर सापडेल. तो एरर आपल्याला बॅकवर्ड प्रोपोगेट करायचा. Backward propagate करायचा म्हणजे here you see once we get some predicted probability of the output, right? So we penetrate this particular area to adjust. Here we have weights, right? Here we have weights and biases. So we adjust that error uh, with the earlier weight and biases. We modify, we update those weights and biases so that in the next iteration, it will come up with the better results, right? So in the next iteration, it will come up with the better results closer to the targeted value of the neural network. Okay, now let's see. Now you see here, we have in the structure, we have initialization of constructor initialization, then tanh, sigmoid, these are the activation functions. This is the forward, okay, learning, the structure of the forward, and this is the backward learning, okay, backward propagation. Okay, we will go through this concept one by one. Then we'll start the training. We'll go to the main program here. This is our main program. This is where the program starts. We have a learning factor with 0.5 and hidden layer size is 4 nodes, right? So once we pass this input data, that is X and Y, to the neural network, okay, and we start training. And once we start training, we call this activation functions as well, this forward and backward propagation functions here, right? So let's start with the training. In the training, we pass this input and we keep the epoch size by default 1000, but we're passing here 2000 epochs. Okay, so more the epochs, we have to adjust the learning factor, because it 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 takes the number of studies on particular data set, and and then it learns, right? So this is the default value, but here we are passing 2000 epochs. So until the epochs finish, we are going to process these functions. So first is we are going to record the output of the forward propagation, and let's jump to the forward propagation. This is the forward propagation. So this is, we calculate the weight and bias factor for the hidden layer. So this is layer one, where forget, we are just providing the input. Okay, so we call it as a layer zero, or the hidden layer, that is layer one. So in the layer one, we do the dot product of the weight and biases, and for the output, we do the activation function, right? So we are using activation function for the hidden layer as standard. बॅकवर्ड प्रोपोगेशन फॉरवर्ड प्रोपोगेशनमध्ये तुम्हाला सर्वात पहिल्यांदा वेट आणि बायस फॅक्टर्स डॉट प्रॉडक्ट तुम्हाला आपण प्रोव्हाइड करतो, आणि त्याच्या थ्रू आपल्याला ॲक्टिवेशन फंक्शन थ्रू आपण ते जनरेट करतो आउटपुट, राईट? आणि once we do that, right, we are going to use those weightage, the output of the this first hidden layer, we provide it to the here. If you see output of the hidden layer, this is a output of the hidden layer, we will provide it to the next layer. So what is the next layer? Here is the output layer, is the next layer. The output layer मध्ये आपल्याला we see the dot product of the output, and like weightage, and we add it to the bias, and this is the output of the sigmoid function, and ultimately we get the output of the, that is self dot a2, is nothing but the output of this particular node. So that will be close to the 1 or 0 as per the learning we see. Okay, so this we jumped here, and we gathered the output. Okay, so once we gathered the output, we can see that here is the, after this, once we got some, we get some certain value here in the output, right? Maybe 0.4 after this learning, right? 0.5 or 0.3, whatever, 0.7, whatever, right? So once we get this, now we are going to compare uh, each time. Okay, are we close to the target? Are we close to the target? The output of the output layer, is it exhibiting the similar result closing to the target? Yes or no, right? So after that, we are going to adjust. Here comes the backward propagation. Guys, this is very important concept, because the actual learning that is taking place is into the backward propagation layer. So guys, in the training, let's move with backward propagation. This is the function. I'm just giving you a superficial information about this program. In detail, step by step, we are going to see the simulations sooner. So this is the backward propagation function here. This is the output layer error. So what is mean by that? Like we are going to get some error. Like we have got the output here. So we have got the output here, right? Here we have got the output. We are comparing with it with the y. So this particular thing, and in the hidden layer, the output of the hidden layer, we this error, we calculate, we do the dot product of this error and the weightage, right? And then we have like we can see the tan H and sigmoid derivatives. This is we call as gradient because we want to tell neural network. आपण न्यूरल नेटवर्कला सांगतोय की एवढा एरर आलेला आहे तुझ्या आउटपुटमध्ये आणि हा एरर तुझ्या नेक्स्ट लर्निंगमध्ये ऍडजस्ट कर राईट so that it will in the next step it will learn it will adjust the weight and bias in a such a way that it will go closer to our targeted value, right? Not exactly to the target value, but it will go closer to the target value. We'll see it into the simulations. So once we achieve that adjustment, we are supposed to this is the adjustment of the error. Like we have dz1 with the output and this tan h derivative, we are going to update the weights, right? So we have weights W2 by as well as W1. So that is the formula, okay, to adjust weight. So like old weight minus the new, adjusted the difference of the output of the like A1 and uh, dot product of A1, that is output with the differences, right? So we have difference, right? So output and differences. So similarly for the bias, right? So we have self-learning rate, right? 0.5. So B2 is equals to B2 minus self-learning, this entire particular expression. Sum of, this is the difference, right? And then similarly, W1 and W2. Okay. So once the backward propagation is finished, okay, here these are the stages in the epoch. We have 2000 epochs. Out of that, we are going to see and track down the progress of the program. तर आपण जी लर्निंग प्रोग्रेस आहे न्यूरल नेटवर्कची ती आपण ट्रॅक करणार आहोत फॉर द each epoch 200, right? The epoch 200 means once we got the into the step 200, we can see okay how the neural network is learning, right? Neural network कसा शिकत आहे, right? So we clip the output after the epoch 200, 400, 600, right? So we clip the current output, and we are clipping it because uh, the output can be zero, so it will lead to the infinite. So we clip it. So we are making an interval which is more than zero and less than one. So I'm interested to know the output which is more than zero and less than one, right? So that we will come to know how the program is learning, right? तर यामध्ये तुम्हाला इथे भेटेल. This is our loss function. So what is loss function? Loss function tells us this is a parameter. This is a very important parameter so that the program will tell us how uh, gradually the program is learning. Okay, so this is one of the factor. हा एक असा फॅक्टर जो आपल्याला सांगतो की प्रोग्राम कसा हळूहळू लर्न करतो. ओके, सो हा पॅरामीटर फार महत्वाचा पॅरामीटर आहे. And once you print this into the output, you will come to know how the parameter is working. And yeah, here you are doing the last predictions. In the last prediction, how it is closer to your target value, and we here print the final value. So this is the entire program structure. So let's move ahead with the how it is behaving, how the neural network behaves. Hey, guys, let's move ahead. Okay, so this is we are going to simulate the things as we understand the XOR problem. This is what input and output. So like single layer perceptrons we are using. And this is the structure of the neural network as I have explained, right? So we have two neurons here you see as input, okay, as input, and there is, okay, so we have four neurons into the hidden layer. So you can take more neurons, but more neurons will take you to the overfitting of the output, and overfitting of the learning, and less number of neurons will give you the you know underfitting of the learning. So you have to put the hidden layer neurons concise figure so that it will be appropriate for the learning. And output layer, we have one neuron which will do some a binary classification, like in the XOR. It's like zero for this combination. Should be zero for this combination. There should be one, and so we have two input layer for hidden neurons, and an output layer one. So let's understand, one by one. So initialization, we have weightage factors. Okay, so we provide a weight factor for this is the weightage for each of the input, right? And this is the weightage for W1 for the hidden layer, W1 weightage for the bias. This is the um, vector. So this vector is the weightage for the input. Like you see, we have four inputs, right? Input in the input one, we have four inputs. Input in the input two, we have four inputs, right? So here, input one, we have four weightage for these four inputs. Okay, so it generates random. So we have used, and as you see, we have used a random function that will generate the weights. Okay, so and you see, this is XOR. So in the initialization, we have four inputs, input one and input two, four. And the weightage, the hidden layer, we have four weights for the four inputs, for input one, for input two, four inputs for the input two, right? So for the bias, we have uh, four nodes. So we have uh, bias vector for the hidden layer, right? Bias vector for the hidden layer. And this is the weightage factor, right? This is the weightage factor for the output layer, and we have the bias layer. Uh, Sorry, we have the bias for the output layer. So let's take the input we see. It's very simple to understand, right? So we let's take 1 0 0 input, and how the program behaves. The program behaves like hidden layer calculation. So it it prepares the total output, right? It prepares the dot product of the weightage and the bias, right? But the thing is that here we have the input with 0 0, and so we got this particular vector z1 and a1 as a 0, right? So in the output layer calculation, we got the 0 as we have got the output with the weightage, the uh, output layer calculation of the hidden layer with the weightage of the output layer. So it gives you the 0 as the sigmoid of the 0. We got it as a 0.5. So this is one of the output layer. So what we got is the output of 0.5. Okay, for the input 0 0. So how the neural network learns? Uh, this is one of the input which will help you to understand how the neural network runs. So in the input layer here, we are providing the second input like 0, input 1, and 1 as input 2, and we are expecting the target, that is y, is 1. So in the input, in this particular input, the hidden layer is like we have 0 and 1 as input, and we get the dot product along with the weightage. This is the random values, And after this all dot product and with the bias calculation, we got this particular, okay, the figure of side one. So the total like activation function, as I have told, activation function क्या होता है? The nodes activate करता है. So how the nodes are getting activated on the values of the set one, right? So you know the tan H and sigmoid activation function. You can refer it through the YouTubes, or you can refer it to the basic neural network any book, right? Activation function. So in the A1 we have got this particular. So this is the output which tells the probability of our output. Okay, so our output layer is like after calculating this one, the output of the hidden layer A1 with the biases of the output layer, with the weightage of the output layer plus bias. So output of the hidden layer one node with the weightage of the uh, this output layer, and this is the second node. This is the output of the second node with the weightage into the dot product weightage of the output layer. Okay, so what we have got is this is the value. So the activation function, as we could see, this is the activation function for the output layer. Okay, this is the output layer. So we are using the sigmoid activation function. So sigmoid will decide what the final predicted probability value, which is maybe closer to the y target or may not be. Okay, so let's go here and see that we have got the output layer calculation. The final output is 0.439, right? So similarly, you can do the calculations, and how the program will run, we will see sooner. Okay, so let's go to the how the backward propagation weight gets calculated, right? So the like for single training example like 0 1 with target we have 1, and training example with input 0 1. Okay, so as we see with the 0 1 example here, right, with the 0 1 input we are getting this output, right? So output is, we are expecting output what? 1. What we are getting is output 0.43, right? So that is the difference. So the error is this much is the error. So now this particular figure is very important to back propagate it to the neural network, so that the next time the neural network understand, oh, this is the error, and I have to adjust my weight and bias with this particular error, right? So next time I will adjust the weight and bias, and the next time let us see. Once it is adjusted, then we will see again the output that is exhibited is closer to the targeted one or not, right? So so this goes on like forward, backward. This goes on, right? So after providing, we have got the error. So like we have gradient functions to calculate the errors and propagate, right? So what gradient is? Gradient is how once we get the error, we have got the error. Now we are telling the now we have got the error here. We have got the error. Now we are going back, right? This is backward propagation, and we are going to tell all these hidden layer nodes, okay, boss, you have to adjust your weights and bias and come again. Okay, come again with the solutions, right? So how we are going to tell is that, so we have derivatives, sigmoid derivatives. We have sigmoid derivative here. So how we going to calculate this? The standard this one output into the error into sigmoid derivative. Okay, so we calculate the delta W2, that is the weight of the output layer. So what would be the change in the weight of the output layer? Then the like, delta bias, what will be the change? This is delta B2. What will be the change into the bias of the output layer? Then propagate it. Then in the hidden layer error, so once we get the W2, we the output, the weightage of the output layer into the error and tan derivative of with the A1. Right? So once we do that, we have got this. Like this is the formula where we have adjusted here. So update weights. This particular code execution is similar to this concept. So W2. So next weight will be old weight. So this is the old weight minus learning into learning rate into the changed weight, right? So this is the new weightage of the neural network for the hidden layer, right? And this is the new bias. So old bias minus learning rate into the changed bias. Because why it is changed? Because we have got the error, right? So we are adjusting that error to the adjusting that error to assume the new values for the weight and bias. So this is W1 is like the weightage, like you see. So we have got this W1, we have got this W2, right? So we have to tell, okay, so for W1, the learning rate into the input and hidden error, hidden layer error. Okay, so at every step they have generated error. So input into the hidden layer, hidden error. So this is the new biased value. This is the old biased value. This is learning rate into hidden. So after the successful execution of the program, how you will see at the epoch 0, that is epoch is nothing but the you can epoch. What is an epoch? Epoch is you don't give a data set for learning only once. You give the same data set to the neural network again and again, again and again, the entire data set. And each time it comes with the more learning. Okay, so we have set the epoch to the 2000. So in the first epoch, you will see that we have provided the input like 00 and we got the output like uh, 0.5. You see here for the 00 input आपल्याला काय भेटलं होतं? What's that for the 00 input? Okay, the final output 0.5, right? So similarly, like for the input this much. So like input for input 00, we got the output of 0.5. But what it should be? It should be 0. Then for the input 01 or for the input 01, we have got the output of 0.44. But what is the target? Our target is 1, right? So we are telling if the input is 01, I should be getting 1. It's very simple. And if the input is 0, I should be getting 1. If the input is 1, 1, I should be getting 0. But what we are getting, this is the probability figures. Okay, these are the output of the learning, right? So we are getting this for 0.44 instead of 1. We are getting output 0.42 instead of 1. We are getting output 0.388 instead of 0. But once it keeps learning, you will see the progress. Okay, here is the loss function. You see, this is the loss function value goes goes gradually less as the neural network learns. The loss function value becomes less at every epoch, right? So at the epoch 2000, if I provide the input 00, it gets me the output 0. That's correct. I should be getting output. Then if I provide the input 01, I should get the output 0.99, which is closer to 1. Input 10, the output should be 0.99, that is closer to 1. That's correct. And for input 11, the output 0.01 is correct. And the loss function value is very less, that you can see, right? So this is the explanation, and let us see how the things work here. And we go here and we run this and see how the program behaves. So I have run this program and just see how this program behaves. So let's start with this. So this is the first initialization. We have W1 shape 3 comma 4. That is, there are two inputs, and we are providing these two inputs to the different 4 nodes, right? So we have two inputs, input 1, so input 2, and we have got some weightage, some value, random values. Now, initially we will give that, and then we will adjust the weightage, okay, as per the learning and errors. So this is the initial. So like shape 1, we have bias B1, okay, and stability shape, we have 4 comma 1. So this is the weightage for the, you see, these are the 8 values here. You see the 8 values: 1, 2, 3, 4, 5, 6. So for this 1, 2, 3, 4, 5, 6, 7, 8, right? And then we have 4 values here. These are the weightages for the output layer: 1, 2, 3, 4, right? So this is the shape of the bias and values of the bias. So for epoch 0, we have clipped the output 0.5, and we have a loss function. It's a huge value, loss function, right? So these are the clipped output. Clipped output means for more than 0 and less than 1, what is the output, right? So for epoch 0, we have this particular value, and the prediction was this one, like 0.5. This was the prediction at the epoch 0, right? Then comes, then we skip all this and we move ahead with each step for epoch 200, for epoch 500. So we are just observing and tracking the progress of learning of the neural network at each 200 epoch, right? As at its progress. So we have got, you see, it is moving closer and closer each time to the target output, right? So epoch 200, it has clipped. You see the difference. At epoch 0, this was the value for that input, for that output, and this is the output value after epoch 200. Okay, so now you're getting how the neural network is learning. And here we see the less loss function value. Loss function values going gradually less. So we have got the formula here. We have got the formula for the loss function, as you can see. So we like this is the formula for the loss function, that is log of log of the predicted output and target output. Okay, so this one, let's go here to the, and you can see that. So after the epoch 400, we have got these values, output values, and you see this is the value, and this is you see these are the positive values, and it is going more and more precise and accurate values near to one, right? So like this, you see here the last one, it is going to the precise value, okay, after each epoch, and after two 2000 epoch, what we get is the final value is this. So what sigmoid function does is, also this is zero, fine, and 0.99. Okay, so what this activation is showing is, okay, so I have got like 0.99. Okay, this has to be 1. I got 0.993. This has to be 1. I got 0.001 after this, and so finally the round predictions like 0.1110, right? So like we have got this round predictions, you see. So like this is how we have got these values by one. So uh, uh, this I have explained here in this particular thing. This will be very helpful, uh, you know, a guideline file, right? The third file, so that you can compare the behavior of this program, the simulation with this program here. Okay, I hope you understood the concept of the neural network, and we have simplified one of the example XOR, the problem statement of XOR evaluation, and through the neural network. Yeah, thank you very much for uh, for uh, viewing this, and I hope you understand this. Guys, if you like this video and if you understand the concept, please like and subscribe my channel. And if you have any queries or any doubts, you can come to my GitHub. I'm providing this link into the video. And if you have any questions or doubts, you can put comments to my video, and we will discuss there. Yeah. Thank you very much.